What does the grass here in the foreground, that ship off in the distance, the clouds, what do they all have in common? What are they all made of? How are they moving? Where are they getting their energy? What is energy? This is the first part of a video series I'm doing that I'm calling What I Think Every Adult Should Know About Science. And I'm doing this to give people a solid, basic understanding of how scientists look at the world so that you can stop there and just feel like you have a basic understanding, or you can explore things in more detail. I think a lot of the way we learned science in school got us bogged down in memorizing detail, and the big picture was not emphasized enough. Putting those details in context, why are they meaningful? So it's my hope that these videos have minimal jargon and technical stuff, and as simply as possible put across the basics of what I think is a firm kind of knowledge of science for today's world. And I do private online tutoring. My website will come up here in a second on the screen, and you can go there and, ooh, there's a hawk, and get in touch with me if you would like to set up some tutoring or just chat. Okay, hope you enjoy the video. So when scientists look at the world around them, they notice basically two things, and they study two things, and that's stuff and stuff moving. Or you could say stuff and movement, which they call matter and energy. So stuff and movement. And again, technical words for those are matter and energy. Now, I can't resist letting you know right off the bat that what we perceive every day as reality is very different from what physicists have discovered is behind that reality, sort of the reality behind the reality. And I'll talk a little bit about that at the end of this series. It's very, very strange. It's nothing like what reality seems like. But let's stick to what reality presents itself to us as. And let's talk about the stuff part, the matter. So matter or stuff is stuff. It's anything you can see and smell and taste and touch and all that good stuff. It's things like cars and people and rocks and trees and gas and the air. Now, for our purposes in these videos, we're going to zoom in on matter up to a certain point. And beyond that point is when it gets weird, but we're going to stop before it gets too weird. If you zoomed in on any matter, a rock or your finger or a table or anything, you'd find three basic particles. And those particles are protons, neutrons, and electrons. Now, for our purposes, just think of those as little balls, tiny little BBs or something. What they really are, don't get me started, but we can think of them as little tiny BBs, and every proton is the same as any other proton. So if you pulled a proton out of an ant and a proton out of a rock, theoretically you could switch them and it would make no difference. They're like interchangeable little building blocks, according to scientists. And the same is true for neutrons and electrons. Think of them as generic particles. Now, these protons, neutrons, and electrons are small, incredibly tiny. Just to give you some idea, in a grain of salt, here's some grains of salt next to a penny, there are about this many protons. Okay, I don't know what to call that number except big. And I can just tell you as an aside that scientists would write that number not with all those zeros, but they'd represent it this way in what's called scientific notation. And that's because the 19 tells us that this decimal has to be moved 19 places back, and that would give you this number, moving the decimal back there. But don't worry about that right now. I'm just saying protons, neutrons, and electrons are incredibly tiny, and there is a massive number of them in even the smallest bits of matter. Okay, so if all stuff or matter is made up of just those three little particles, what makes matter different from other matter? What makes carbon, say, different from gold, or hydrogen different from oxygen, And what makes just anything you see, like a couch material, say, different from a piece of metal? Well, it's about the arrangements that those three particles get together in that makes the difference in the materials that we see. So let's talk about how protons, neutrons, and electrons get together and form what we call atoms, which is the next level up in size from protons, neutrons, and electrons, but still incredibly tiny. And to give you another example, in a modern penny, which is made of zinc and copper, there are about 2.3 times 10 to the 22 atoms in a penny, which is this number. All right, so lots of atoms in everything. All right, so I'm going to draw a representation of a specific atom that probably you've heard of, a carbon atom. A typical carbon atom has 6 protons and 6 neutrons, which I will make gold. All right, so here's our protons and neutrons. Let's label them. And they get together in a little area that we call the nucleus. It's like the center of the atom. And then farther away from the nucleus are the electrons. Let's make the electrons red here. And a carbon atom will often have 6 electrons. And I just put the electrons a distance away from that center area that we call the nucleus, but it's not accurate at all. None of the scale here is accurate, and of course none of these things are actually these colors. But this whole thing we call an atom. So let's say this would be one atom of carbon. Okay, so one atom of carbon would have 6 neutrons, 6 protons, and 6 electrons. So you can see that there's a lot of space in an atom. And in fact, if we blew up an atom to the size of, say, a football stadium, and we made the nucleus in the center of the field, if the nucleus were about the size of a pea, the electrons would be way out on the outside of the stadium. And the electrons are actually a lot smaller than the protons and neutrons. So most of an atom is empty space. It's that huge football stadium with just a tiny nucleus in the middle of the field and even tinier electrons way out on the outside of the stadium. So it turns out there's only 92 naturally occurring kinds of atoms. And they range from an atom with only one proton, that can't have any less than one proton, up to 92 protons. And it's the number of protons that really makes an atom a certain kind. So let's look at all the known kinds of atoms. You remember this from your chemistry class? This is called the periodic table, and it shows us all the known types of atoms. And the kind of atom you are depends on how many protons you have. That's called your atomic number. So this number up here in the upper right, that's for hydrogen, that's just a representation of that, is the number of protons. That's the number of protons that a hydrogen atom has. Then the next one up would have 2 protons is helium. And then lithium, you can see, has 3. Something called beryllium has 4. Boron has 5. Now a little bit more well-known elements. Carbon atom we just talked about has 6. Nitrogen 7. Oxygen 8. Fluorine 9, etc. All right, some of the celebrity atoms. Let's skip all the way up here to gold. 79 protons. Silver back here with 47. And then we've got iron has 26 protons. So if you look around you right now, wherever you are, everything you're looking at, the trees, a couch, a car, your hand, is made of some combination of these 92 different kinds of atoms. It's just how they're arranged and how many of each and all that. And some are more common around you right now than others. So whatever you're looking at right now, there's going to be quite a bit of carbon, for example, and oxygen and hydrogen and maybe some iron and stuff like that. And these different kinds of atoms are also called elements. So you'll sometimes hear the element carbon. That just means a bunch of carbon atoms. Now, the other thing about these atoms is they can neither be created nor destroyed. So you're not going to have a carbon atom disappear. And that law or rule that stuff can't be created or destroyed is called the law of conservation of matter. I don't want to get bogged down in these technical names. I just want you to know the basics. So, all the atoms around us have been around for billions of years. At the beginning of the creation of the universe, these different kinds of atoms were formed, and they've just been recycled and circulating all around into and out of various things. And I'll talk more in future videos in this series about that kind of cycling through things. That's what that song, We Are Stardust, means. We're made of the same atoms that were in the stars. Okay, and also amazing is all these atoms are just combinations of three basic particles: protons, neutrons, and electrons. So again, when you look at stuff around you, you're just seeing different combinations of three different fundamental particles: a rug, the air, your hand, an ant, a rock. All of these very different things are made of these three basic building blocks. Okay, see you in the next video.